Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, we are going to continue part 2 for chapter 1, Introduction to Database System. Okay, in the part 1 video, we have covered 3 chapter objectives, which are the difference between data and information, what database is, the various types of databases, and why they are valuable assets for decision making, and the importance of database design. Okay, in this video, we are going to cover the rest of the chapter objectives, which is the main components of database system and the main functions of database management system. Okay, we start with the problem with file system data processing. Actually, I have missed this slide in the first video, so I include it in the part 2 video. It is basically regarding file system data processing, right? If you remember that the file system data processing basically is a manual process and typically composed of collection of file folders, which is kept in the cabinet or in one place, right? So what is the problems with these data processing types? Okay, the first one is even simple file system retrieval tasks require extensive programming. 3GL procedural language, for example, C, okay, and ad hoc queries impossible. Okay, ad hoc queries is, for example, you want to do a command like a SQL statement. I think you have experience during your installation. You select something from employee table. For those who has complete doing your installation, right? You have experience on ad hoc queries, which is impossible for file system data processing. Okay, and changing existing structure is difficult. Meaning that in the structure of data which is stored in a file is difficult to change, because if the changes happens in the one file, it's supposed to be updated into all files related to that data. Okay, so next is security features difficult to program, which is often omitted in file system environment. Meaning that if you park your file system data in many places, so in terms of security, you might it might happen that the security only apply to a certain places only. Okay, so if let's say you have a 10 places stored the same file with the same data, it might happen that only 3 is secured but the other is not. Okay, it is because it depends on the file system environment, how you configure the security, okay, security setting and so on and so forth. Okay, lengthy development times, meaning that when you are using a 3GL is a third generation language procedure. Okay, uh, for sure it needs more time. Okay, longer time. So, and the next one is difficulty to getting quick answer. Okay, because all the process need programming, right? Okay, next is system administration is complex and difficult. Okay, because more difficult as the number of files in the systems expand. Okay, uh, it is a quite clear statement, because if too many files, it's for sure the administration is complex, right? Okay, lack of security, okay, requires extensive programming, which is a 3GL procedure language, and difficult to make changes to existing structures. Okay. Okay, next topic is structural and data dependence. Basically, the limitation in file system data processing have led to structural and data dependency problems. Okay. Okay, structural dependence happens in file system data processing, which is access to a file is dependent on its own structure. Meaning that if you want to change the file structure, I think I explained it in the previous slide. If you want to change the file structure, all file system programs must be modified to conform to a new file structure. Okay, and conversely, for structural independence, where any changes to file structure will not affecting data access. Okay, so in other words, when you make any changes in the data storage characteristic or data structure, it won't affecting the application program. Okay, next is data dependence. Basically, when any changes in field of in the field I mean a data structure. For example, you want to change a data type from integer to decimal. Okay, for file system, it is required changes in all programs that access to the file. Okay, again, this is the file system data processing problems. Okay, and is conversely with the data independence, where data storage characteristic changes do not affect data access. Right. Okay, data redundancy. Okay, actually, in the file system structure, uh, it is difficult to combine data from multiple sources, and its lack of security renders the file system vulnerable to security breach. Okay, because the organizational structure promotes the storage of the same basic in different locations. Um, Normally, database professional use a term island of informations, uh, which is referring to the situation where the informations often contain different versions of the same data. Okay, when this happens, by having data stored in more than one place, will produce data redundancy. Okay, and data redundancy exists when the same data are stored unnecessarily at different places. Okay, and data stored in different locations is unlikely to be updated consistently. Okay, so because of the uncontrolled data redundancy, it leads to uh, the first one is data inconsistency, which exists when different and conflicting versions of the same data appear in different places. Okay, for example, if you want to change phone number in customer file, okay, just imagine about the file system data processing in the previous slide. Okay, for example, if you want to change the phone number in customer file, okay, but forget to change phone number in agent file system. Okay, so the data output will get inconsistent result because it depends on which version of data used. Okay, so the second one is data anomalies. Anomaly is referring to an abnormality, which is data develops when all of the required changes in the redundant data are not made successfully. Okay, uh, and it is found in three common activities, which are update anomalies, insertion anomalies, and deletion anomalies. Okay, let's do some exercise. Okay, when you look at these tables, okay, what data redundancy do you detect, and how could this redundancy happens? Okay, look at this table. You can see Holly Becker under column project manager. Holly Becker is the same person with the same phone number and address. This is called data redundancy. Okay, choose data redundancy is the same data stored unnecessarily in different places. Okay, so but it is this data is pointing to the different project code, right? This one, sorry, this one. Okay, so because of this data redundancy, uh, uh, this situation will lead to anomalies situations, which mean when you do changes or update data for redundant, okay, it will not update correctly or perfectly. Okay, for example, if you want to update the name, I mean Holly B. Packer to someone else, or the address, okay, the address, it might update it only to one row. Okay, it is based on the command. So if you want to exactly update all data, you have to have three different commands, so that the data will be updated. This is the problem of data redundancy, right? Okay, now we move to a database system. Okay, database system consists of logically related data stored in a single logical data repository, which is maybe physically distributed among multiple storage facilities. And DBMS eliminates most of file system problems. Okay, this is what DBMS, and we are going to learn about DBMS after this. Okay, this figure show a differentiation between a database system and a file system, right? Database systems provides numerous advantages over file system management, okay, by making it possible to eliminate most of the file systems data processing problems, such as data inconsistency, data anomaly, data dependency, and structural dependency problems. Okay, if you look at file system, each department has their own file system. Okay, meaning that their own database. Okay, if you are using a DBMS, all departments can share one database using DBMS. Okay, this is how the database design happen to solve a file system data processing, right? Okay, the database system environment. Database system is a term that refers to an organization of components that define and regulate the collection, storage, management, and the use of data within the database environment. Okay, uh, five major parts of database system, which is hardware, software, people, procedure, and data. Okay, this figure explains those five components, which is the hardware, for example, computer or workstation or server, and software, which installed in the hardware, must include operation system, okay, DBMS software and data, and also application programs and utility software that use to access and manipulate data in DBMS. Okay, people, okay, people. This component includes all user of database system. Okay, on the basis of primary job functions, five types of users can be identified in a database system, which are system administrators, database administrators, uh, database designers, system analysts, and programmers, and also end users. Okay. Okay, next is a procedure and standards. Okay, procedures are instructions and rules that govern the design and use of the database system. Okay, and the last one is data. Data is data is a collection of facts stored in database. All right. Okay, hardware, all systems, physical devices. Software, three types of software. operating system, DBMS software, and also application programs and utility software. Okay, next is people's, okay, procedure and data. You can read this by yourself. Okay, DBMS function. Okay, basically, DBMS performs several important functions that guarantee the integrity and consistency of the data in database. Okay, most of the functions are transparent to end user. Okay, and most can be achieved only through the use of a database. This is how how when you use the DBMS, you know this. Okay, at the moment you just take it as a theory. Okay, so so the functions will include data dictionary management, data storage management, and data transformation and presentation. Okay. Okay, this is how the DBMS will be look like. Okay. Okay, for example, in your DB2, you can imagine it is in IBM Studio. You can see a window where it can appear all the list of databases and also the metadata. Metadata is a data about data. Okay, data about data meaning that database, what is the structure, okay, and the characteristic of the data. All those is metadata. We call it metadata. Alright. These are the other DBMS function, which is a security management, a multi-user access control, backup and recovery management, right? Data integrity management, a database access language and application programming interface, and also database communication interfaces. Which is interfaces. It allows database to accept any user request within the computer network environment. So this all these DBMS function you will experience to use during your lab session. All right. Okay, the database system makes it possible to tackle more sophisticated use of data resources. Okay, as long as the database is well designed. So, although the database system has many advantages, okay, but it is also has disadvantages, which are it will increase cost, okay, management complexity, maintaining currency, vendor dependency, and frequent upgrade or replacement. Okay, uh, all the explanation about the disadvantages you can read in the book. I give you the link of the book, right? So I can read what the explanation about each of these disadvantages of the database system. But I think you can read in book. Explore yourself, right? Okay. So as a summary of chapter 1, okay, data are raw facts. Okay, information is the result of processing data to reveal its meaning. Okay, accurate, relevant, and timely information is the key to good decision making. Okay, data are usually stored in a database, and DBMS implements a database and manage its contents. Okay, so metadata is data about data. Okay, database design defines the database structure, which is a well-designed database facilitates data management and generates valuable information, and poorly designed database leads to bad decision making and organizational failure. Okay, databases evolve from manual and computerized file systems. Right. So in a file systems, data stored in independent file, which is each requisite requires its own management problem. Okay, so some limitation of file system data management, which is requires extensive programming, for example C language. Okay, system administration is complex and difficult, changing existing structure is difficult, security features are likely inadequate, and independent files tend to contain redundant data, and also structural and data dependency problems. Okay, so database management system would develop, okay, to address file systems inherent weaknesses, right? So DBMS present database to end user as single repository, which promotes data sharing and eliminates islands of information. Okay, DBMS enforce data integrity, eliminates redundancy, and promotes security. So I think that's all for chapter 1. You can do exercise for these questions. Okay, thank you.